Welcome to another edition of Physics. In this case, we will be presenting fluid mechanics, and the problem is the next one. The problem says Chonito the crocodile is waiting for the prey while floating with just the top of his head out of the water. In this way, he remains unnoticed. To control how much does he sink, he swallows stones that remain in his belly. The figure at the right shows a simplified model of Chonito, with a mass of 130 kilograms, and his head showing out of the water. The top surface of his head has an area of 0.20 meters squared. If Chonito swallows the equivalent of 1% of his body mass in stones, how much will he sink? As always, we have to start sketching our problem. Here we have Chonito under the water with an area over his head of 0.2 meters squared, a mass of 130 kilograms, and he is sunk by a height h. Then he sinks a little bit more, and by consuming 0.01 of his original mass, which we have here. So now he will weigh his original mass plus 0.01 from his original mass. Next, we have that the buoyant force, that is the force making it sustain at that level, will be equal to the mass per gravity, which will be in equilibrium. So that gives us density plus the total volume, which is volume 1 per volume 2 per gravity. Why this? Because this would be the mass, but we know that the mass is the density per the volume. So next thing we do is we try to match these two cases, for which the second m, which is m plus 0.1 m, equals the density plus of the water per the volume plus the density of the water per the second volume. So we can, and in the lower part we have all of these, but without the consumption of the rocks. So we can see that these two terms are equal, so we can eliminate those. And well, since this one is given by a difference of 0.01, we have that 0.01 of the mass equals the density per W per V2 prime minus V2. So V2 will be A per H plus delta H, which leads us to the next part. This will give us 0.01 m per delta per area per delta H. So from this formula we just have to set things up, rearrange the formula so that we have delta H equals 0.01 m over the density of the water per area. We have all of these values. We have the mass of the crocodile, which is 130. We have the density of the water, which is 1000, and we have the area of his head, which is 0.20. So we just have to substitute, and this will give us our desired value, which is 6.5 per 10 minus 3 meters. That was it. I hope you enjoyed it. I hope you understood well. Any doubts, you can comment below. And see you next time.